All right, so one of the things that I want you guys to understand is that even though these electron configurations and these orbital diagrams may look, they may feel, they may act very confusingly, but I can promise you, once you find the pattern, once you find the method at which it takes to complete these things, you are going to fly through them. They are simple, but there is a method to it. Okay? And so what I want to show you guys today is how we approach the method. So first of all, you understand kind of what's going on. I want to go back and show you this hierarchy thing we talked about yesterday. If I can find it. There it is. Hierarchy. Okay? So it's a system of how things are developed and set up. So the three words that are odd to you were energy level, sublevel, and orbital. Okay, now obviously you know what an electron is. And whenever we're looking at these particular things, you have to understand that what we're trying to do is find the location of electrons within an atom. Okay, and it's all based off the periodic table. We can pick any of the 118 elements and do this with it. Okay? But it's important that you understand several things. First of all, you understand what the energy level is. The energy level is the easiest thing to determine as far as looking at the periodic table. And because it's going to be what period number it's in. So if you look at it from this perspective, essentially, we have this to deal with. 1, 2, 3, 4, 5, 6, and 7. Now, let me go ahead and tell you. We're not going to deal with any of those down there in that bottom row. Don't worry about it. You're not going to see any of those. Now, based on the POGL yesterday, one of the things you guys should have seen, or you may have seen in some of the other stuff that you've worked on, is the blocks. And that is where this thing called the sublevel comes into play. There are 4 of them. Does everyone know what I mean when I talk about the bed of this? Do you know what I mean? Okay. All right. So let me go through this. First of all, the periodic table looks like a bed if you really look at it. Okay. So let me show you how it looks like a bed. The first thing we have is we have an issue with the foot of our bed. Okay. What's wrong with the foot post of our bed? There's a chip in it. Okay. So because there's a chip in it, we have an extra piece that we can use to fill that chip with. And what is it? Helium. We can take this helium and we can move it over here and fill this chip in, and now it's going to be solid. Now, if this were a bed, and the way I always ask this question is, how many of you wear socks to sleep? Anybody? Okay. Just depends on how cold it is, right? But most of the time when you wear socks to bed, where do they end up? Somewhere off of your feet. So we're going to say that they end up at the foot of your bed. So this is the region of the socks. So the first 2 columns are the S sub-level. That's the block of what it is. Now, does anyone know the shape of this orbital? Very good. Okay? The shape. And we're going to get into this. Okay? Come on now. Wow, I got to go all the way back. So let me come back to this. Let me insert page after current. So the shapes... So, an S orbital. First of all, an orbital is a 3D region of where an electron may be found. Remember, we've already defined this. Let me show you a picture. This is, again, what I was showing you a second ago. The definition of an orbital is, again, a three-dimensional region around the nucleus that indicates a probable location. And then the next picture we talked about was this. And this is just this area where we hypothetically think electrons are traveling, because what direction are they traveling in? It's a trick question. We don't know, right? Remember Heisenberg's uncertainty principle? It's impossible to simultaneously determine where an electron is and where it's going. Okay? So what are the shapes of all of these things? We've got these orbitals. Okay? These are the shapes of them. The s orbital is in a what shape? A sphere. Circles are two-dimensional. Okay? So coming back to this, the S is a sphere. Now, here's the deal. Remember yesterday when you were filling in all those orbital diagrams with all those arrows? How many boxes did each P level have? 3. Well, notice what the P has. It's got 3 of them. Now, the shape of the P block, very good. It's a peanut. Okay? Now, I'm going to be honest with you. I call it a peanut. However, the rest of the general chemistry world calls it the shape of a dumbbell. Is there a B in there? OMGGG. What is wrong with my mouse? Okay, Skylar, you're killing me with the teardrop stuff. So we've got 3 different potential shapes. Now, this is the math aspect, and don't get caught up in it, but it should make sense. If it's 3-dimensional, how many possible axes are there? 3. What is the 2 you're used to? X and Y. What's the 3rd dimension? Z. Very good. So if you notice, this top one is on the x-axis. The middle one is in the y-axis, and what is the bottom one? The z. Now, I know that looks weird from what you're used to, because z obviously should not be going up and down. What would you call that one? But does it really matter? It's all on 3 different dimensions. It's all on 3 different axes. Okay? So this is the P block. So let's go back and actually, I'm going to throw this mouse across the room. Sorry. Getting violent. So let's go back and let's look at where the P block resides. So again, the first thing we started talking about was this looks like a bed. So this is going to be your P block. And what part of the bed is this? This is your pillow. Okay. This is a really big pillow. But any element in that particular region is in the P block. Now, the key part that you have to understand is that there is a definitive line that separates these things. Okay? Do you agree it's kind of like the 2 sides of the land between the bridge that's connecting them? Now, the 3rd block that we need to discuss is in the middle. This is the D block. This is where your dog sleeps with you. That's kind of gross, by the way. Don't let your dog sleep with you. That's nasty. Okay? This is the D block. So any element, can I talk, please? Any element found in that part of the periodic table is the D block, which is, again, where the dog sleeps. It's the foot of the bed, the mattress of the bed, the pillow part of the bed. You just have to use your imagination. Thank you. Okay? If I had a rainbow that could come out of that, I would, right? All right. But the last block is the weird one. But the good news for the ladies and gentlemen sitting in this room, this is the F block, which represents the floor, or the stuff that you forget about underneath your bed, which a lot of you probably do. Okay? Guys, we got to cover this regardless of how much y'all chitter-chatter. So here's the point of perspective. Every part of the periodic table is divided into 4 blocks. The first 2 columns are the S. What do we call this part of the periodic table? Do y'all remember? Transition metals. All of the transition metals are in the D block, And then this right side region, which is the oddest region of the periodic table, and the reason why is, do you agree that kind of it's where the stair step is? So underneath the stair step, you've got lead and tin and bismuth and all those weird metals, all those solid metals. Then you've got that odd group of metalloids that don't know what the heck they are. And then you've got all of your gases and your non-metals. Okay, so this is the oddest region of the periodic table, is in the P block, but it's still considered the P block. Now, the part of the F block, forget about it. You don't need to worry about it. We're not going to talk about the F block at all. So if anything down there, forget it. Don't pay any attention to it. So the last thing that I do want to kind of cover are the shapes of these things, and Teddy's already said one of them, and that was the shape of the D block. And it's going to be the double dumbbells. Okay, so when I go back and I show you the picture of this, it kind of makes sense. The weirdest one out there is the bottom right. Okay, the one thing you have not seen yet is how many orbitals are in the D block. Well, how many do you have? There are 5. So what I'm going to go back and do is I'm going to prove to you how and why the S only has how many? 1. The P has how many? 3. And the D has how many? 5. Let me prove to you how it's those specific numbers. And I'm going to do it over here on the periodic table. So the first thing we need to discuss is what an orbital is. Okay? Again, an orbital is a probable location where an electron can be found. So yesterday, when you guys started, and instead of drawing boxes, I'm just going to draw lines. Whenever you guys started with a 1s, and you can pretend that this is a box, how many electrons can go on that line? That's it. Do you agree? 2? That's it. And it's always the first ring. It's always the first orbital is the 1s. So what does all of this mean? What's important about this? Before I go any further, do you agree that helium technically is to be sitting right there? All right, so we're just going to pretend. You know that 1 represented what? The floor. It represented the energy level. And what I wrote over here, the energy level is equal to what? Period number. Are you with me? So, since this is the first energy level, it's in period what? 1. Do you agree this is period number 1? Okay. How many things are in period number 1? What block are they in? That's why it's 1s. What are the 2 elements in 1s? Hydrogen and helium. That's it. There is nothing else in this. Does that make sense? Yes. That's exactly what we're doing. We're building the entire atom. Okay? Now, we've already established that this line can only hold 2 electrons. Now, don't scream at me. Those are arrows. They're just half arrows. I can assure you, by the end of this, you'll be doing them just like that as well. You're going to get tired of drawing full arrows. I've been doing this long enough to know, you think I'm crazy now, but you will find out this is the way you're going to want to do it. Don't think I'm crazy, because I know you're going to jump on that train in just a second. So here's the deal. The whole part that we're trying to find is how many atoms we have. So do you agree that these 2 arrows represent 2 electrons? Okay, well, one is hydrogen, the next one is helium. Well, what if I asked you specifically about lithium? How many electrons does it have? 3. Do I need any more? Yes or no? Yes. Can I add a 3rd one to that orbital? Well, I got to start over. I've got to add another orbital. Do you agree with that? Well, let me ask you something. What period number is lithium in? 2. What block is it in? Well, that's interesting. How many can fit on that line? How many arrows can fit on one line? So I have, if I needed beryllium, could I add 2 electrons and take care of beryllium? Do you agree that beryllium still is on the second period in the S block? All right, so beryllium is taken care of as well. So I can get to those two. You with me? But then, what happens if I ask about boring boron? It's the elements on. We're not going to go there. But my question to you is, can I add any more electrons to either of those two lines? Well, I need some more. This is where I was trying to get you to see. We've got to figure out how to draw the P block and how we can do the orbital diagram for the P block. Now, I always do it in brackets because it makes it a whole lot easier. Yesterday when you were doing the Pogel for this, how many boxes went along with the P diagram? 3. Here's why it was 3. You've already established the fact that every line can hold how many? 2. Before I go any further, my first question is, let me actually make this a little better. God bless you. Boron. What floor is it on? What period number? It's in the second period. And what block is it in? It's in the P block. Now, I know what you're going to want to say. Why do I need all those other lines? Because they're possible to be there. It's the next energy level. That's exactly right. But why do I need 3 lines? Here's why. What you said is that each line can hold 2. In the P block, right here, how many different elements are in there? 6. There are 6 elements. There are 6 elements in that orange square. 2 times 3 is, why do you need 3 orbitals? To be able to fulfill all 6 elements' energy levels. Does that make sense? So, if I ask you about nitrogen, my first question is, how many electrons does nitrogen have? 7. Thus far, I have used 4 of them, correct? So how many arrows do I need? I need 3 more. But what you said is right. You read about 2 rules yesterday. One was Hund's rule and one was Aufbau's principle. Okay? Hund's rule is the important one. And I ask this question, and every year it gets less and less and less yes. Do y'all remember several years back there was a show called Run's House on MTV? All right. I call it Hund's House. As in this statement. Hund's rule. Stop. Hund's rule states that if you have an empty orbital, a line is an orbital. If you have an empty room, you must fill it before you double up electrons. So let me give you a real life example. Let's pretend that you and your soulmate forever buy a 4-bedroom house. Okay? Now, ignore the master bedroom because that doesn't count because that's yours. You have 3 additional bedrooms, correct? Let's pretend you have 3 kids. Some of you, that sounds awful, but let's just go with the example. So you have 3 children and you've got 3 bedrooms. Logically, what makes sense? Each one gets their own room. How would you feel if you had 3 bedrooms and you had 2 other siblings and you got stuck in the room with another one that was an empty room? You'd be pissed, right? That's totally unfair. Let's be real. You'd be okay. Sorry, Ethan. I apologize about that, Ethan. Teddy, you don't play into this equation, okay? But my point is that if we follow Hund's rule, this is what we would establish for the electron diagram. This is nitrogen. If I showed you that, how would you know that it's nitrogen? There are 7 arrows, which means it's 7 electrons, and who has 7? Nitrogen. But this is where Hund's rule also comes into play. What then happens when I need to get to oxygen? Did I add an electron? Which means I add an arrow. This is the important part. Do I have any more rooms to fill? I don't have any. I'm out of rooms. Well, guess what? You add another kid, you got to double them up unless you can buy a bigger house. You got to have bunk beds, right? So, my question to you is, which room, which bed, which orbital do I go back to? The first one. This is the second important question. What direction must it be going? Down. Very good. So this is the representation for oxygen. Yes, ma'am. Very good. Okay. Yes, ma'am. You're exactly right. But this is oxygen. When I added one, I went to oxygen. So 1, 2, 3, 4. Orange, orange, orange. So 4, 5, 6, 7. You with me? Okay. But remember, if nitrogen has 7, it must also go through this whole process. So that's a great question. And let me explain it this way. What she said is, if nitrogen has 7 and it's in the 2p, why do you need everything else? This is Aufbau's principle. Okay, this was the second rule that you read yesterday. Let me explain how I explain Aufbau. I call it Aufbau's roller coaster. Okay, what that means is, how do they feel most roller coasters if you're at a theme park? From the front to the back, right? So, in terms of this, you have to start at the lowest possible energy level and then build up. So even though nitrogen has 7, where do you always have to start? You got to start at 1, because you can't get to 7 without starting at 1 first. Does that make sense? Is that a better way to kind of understand that? So remember yesterday in Emory we were discussing this. Question 9 on that sheet yesterday was asking, that's not what I wanted. What is this? Okay. Insert page after current. So question 3 says, why is 3s lower E than 3p? And what I showed most of you that I answered this question for was it showed 1s, and then it showed 2s, and then it showed 2p, and then it showed 3s, and then it showed 3p. And then what I said is this: if this is the nucleus, what happens to your amount of energy the further you get from the nucleus? More energy. So this is more E. Well, what do you notice? You always have to start at the lowest energy level. And who is the lowest energy level? Always. And if you go back and look at all the manager's codes from the Pogel yesterday, every single one of them start with a 1S. Okay? Because you've got to start with that lowest energy level. Now, the last thing that... Okay, go ahead, Teddy. We're going to get to that in just a minute. Okay, hold that thought. Okay, go ahead. Don't worry about that. That was the space taker-upper. Okay. It could be considered that. That's actually good. I've never thought about it from that perspective. The kitchen. I mean, think of actually, what Skylar, you have completely changed my whole perception of it. And here, think about this, guys. When you have most holiday functions with your family, where do most people hang out? In the kitchen, right? That's the nucleus of everything. It's true. Everybody likes to eat. That's where the food is. Everybody's going to hang out in the kitchen. So, and if you think about it from this perspective, if you're in the kitchen, the closest room to the kitchen requires the least amount of energy to get to. So normally the living room is closest because after you're full, you go fall on the couch. It requires the least amount of energy. So if you have to go upstairs to go to your bed, you're not making it, right? After Thanksgiving, after Christmas, nope, the couch. That's where I'm headed. So that's kind of, and again, that's an interesting, a visual concept of a way to look at it. The what? Okay, hold that. We're going to get P or D? D as in dog? Hold that thought. We're going to get there. Now, last little part about this. What if I specifically ask about neon? And this is where it's all going to come to click. Thank you. It's got 10. Thus far, what I have filled in has how many? 7. So I need how many more? We've already established that I come back to the beginning. They have opposite spins, and that happens. What do you notice visually about this diagram? Everything is full. Well, that's interesting. What do we know about the group that neon's in? They're the noble gases. What do we know about noble gases? They don't react because they have a full valence shell. Is it full? That's why they don't react. Because it's full. Yes, ma'am. Shh. What other elements? Okay. Every arrow represents a different atom. That's what I'm trying to get you to see. That if I back one off, how many do I have? Who is it? Fluorine. If I back off again, I've got 8. That's oxygen. You starting to see the pattern now? So every arrow is a different element. If I did the entire periodic table, I would have to have 118 arrows. Now, obviously, that's ridiculous. We're not going to do anything like that. But that's the concept, is that every arrow represents a different atom. You with me those so far? All right. So what I want to do now is I want to test your ability to translate that to some of these questions. And let's be able to find the cheat in this. Okay, let's find the cheat version of this. So stay with me. So let's look at number 1. The question is, write the name and symbol for the elements of the following orbital diagrams. There's 2 things I want to talk about. First of all, I could care less about the name because you know what the symbols represent. So we're just going to do the symbols. The second thing that I need to make an emphatic point on is this. Do you remember yesterday on the POGL, it talked about the manager's code? Okay. What I need you to get across to yourself is this idea, is that manager's code that you wrote is called the electron configuration. Now, please stay with me, because I'm telling you this is going to get you on Monday if you don't know the differences. On the test, I'm going to ask for you to specifically do one of 2 things. I'm either going to ask you for the electron configuration or the orbital diagrams. So, Teddy, what you asked a minute ago was, why am I not doing the superscripts? The orbital diagram uses arrows. That is something, if I were you, I would make a big point to myself that if it is a test question or if it is a worksheet and it says do the orbital diagram, what version do you do? The arrows. If it says do the electron configuration, you do the superscripts. Now, obviously, which one's much easier? The electron configuration is much easier. Yes, you don't do arrows at all. I promise this will all make sense. Let's just kind of stay with it, okay? I promise it'll make sense. So let's go and let me teach you how to cheat on this test, okay? Using the orbital diagram. Here's what I would do. I want to show you 2 methods, because you got to figure it out from both ends. Let me show you the hard way first and the easy way second. I normally do that. Here's what we've got to do. We've got to figure out what element this represents. So, what I would ask you guys to do is only focus on the last orbital. Focus on last orbital. So here's the question. We've got to figure out who is in the 4th row, the S block, and has how many electrons in that S block? 2. How do you know there's 2 electrons? You have the answer? Hold the answer. Open my door back, please. So pulling this back up, we know that we've got to deal with the first, with row 1, row 2, row 3, and row 4. Do you agree that's where we are? 4th row. Where is the S block? The left, the middle, or the right? So it's going to be one of these 2. And who is the second element in that group? It is calcium. That is who this element is. Do you agree? That's the one way to look at it. Let me teach you the longer way. How else could you know that this was... You can count the arrows. Count them up real quick. I promise you, if you count them, it's 20. But do you agree it's a whole lot easier to look at that very last value, figure out what row it is, figure out what block it's in, and then how many within that block it is? Okay? You can do it both ways. You're jumping at the easy at the concrete one, but I assure you it's easier to do it the other way. Let me do one more with you, and then I'll let you do one by yourself. We've got to figure out who 2p and how many 2p's. 2p, 2. We're at number 2. So let's go back to the periodic table. Hang on, last one. So, again, we're in row 1, row 2. Where is the p block? The left, the middle, or the right? The right, and it's 2p, and it's the second one. So who is it? It is carbon. Yeah, it starts this right here. See if you can do 3 real quick before you put it up. See if you can figure out who 3 is. Don't say it out loud. Let everybody have a chance to look. Hang on. Yes. Why is the what? Remember that no matter, it's like if you build a house, and it's a 4-bedroom house, ignore the master bedroom, and you've got 2 kids. You can't have anything in there, right? But you still have the room. So anytime you show the P block, did y'all figure out who it was? Sulfur, very good. Please leave the periodic tables up here on the front counter. So even though you don't use it, you still have to show it. Does that make sense? See you later, guys.